Welcome. Today, we're going to walk through how to build a truly robust, professional security architecture right inside the AWS cloud. We'll be using the AWS Security Reference Architecture as our blueprint to create a real defense-in-depth model.
So, this is the fundamental challenge we're really tackling here, removing beyond the simple, out-of-the-box setups and into a layered security posture that enterprises need for their workloads that absolutely cannot fail. This is all about building resilience and control at every single level of your cloud environment.
Okay, let's dive right into this. This is the architecture we're going to be dissecting today. We're going to follow the complete journey of a request, starting from the public internet, and trace its path all the way through these multiple security layers until it safely arrives at your private backend services. Our journey begins at the very outermost layer. You got to think of this as our first line of defense, designed to stop malicious traffic before it even gets a chance to get close to our core applications and our infrastructure. Here, the key service is the AWS Web Application Firewall, or WAF. Just think of it as a really powerful Layer 7 gatekeeper, one that actually understands web traffic. It's built specifically to block those common exploits like SQL injection and cross-site scripting, to fend off bots, and to enforce your own policies like rate limiting or even blocking traffic from certain countries. And as you can see right here in our architecture, the WAF is the very first component to inspect that incoming traffic. Now, by integrating it with Amazon CloudFront, you get this protection spread out globally, right at the AWS edge, which means you're stopping threats as close to their source as possible.
All right, let's move on to a component that is absolutely central for any organization that needs that enterprise-grade inspection and control over their network traffic. This is the critical piece of the puzzle, especially for organizations that have already invested a ton in third-party security vendors. They want to bring those same capabilities, those same policies, into the cloud. And this whole concept is called service insertion. And the AWS service built specifically for this is the Gateway Load Balancer, or GWLB. I mean, it's purpose-built to let you transparently insert a whole fleet of virtual firewalls from the vendors you already know and trust directly into the network path, and you can do it without these complex routing gymnastics. And this illustrates the flow just brilliantly. So traffic hits a GWLB endpoint. That endpoint forwards it over to your firewall fleet for deep packet inspection. The firewalls do their thing, they analyze it, send it back, and then the GWLB routes that now clean traffic to its final destination. It's a totally seamless bump in the wire that gives you incredible visibility and control. Okay, so with the edge and our inspection layers firmly in place, let's build on that foundation. We're going to dive a little deeper now into the network controls that operate right inside your virtual private cloud, or VPC. Now, this is probably one of the most common points of confusion, the difference between security groups and network ACLs. If you remember one thing from this whole section, let it be this key distinction. Security groups are stateful, while network ACLs are stateless. And that single difference, it dictates everything about how they operate. For anyone with a traditional networking background, this analogy is perfect. A security group is basically a mini firewall attached directly to the network interface of every single one of your EC2 instances. And because it's stateful, it means if you allow inbound traffic, the return traffic for that same connection is automatically permitted. It remembers the connection. In contrast, a network ACL, or a NAC, operates at a higher level, at the subnet boundary. It's much more like a traditional router ACL. And because it's stateless, you have to explicitly define rules for both inbound and outbound traffic. It's a broader guardrail, filtering traffic before it can even get to your instance's security group. Now, what's really interesting here is how this table breaks down those operational differences. Security groups, they're your everyday workhorse. They only have allow rules and they're applied right at the instance level. NACLs, on the other hand, are more of a specialized tool. See, they support both allow and deny rules, which makes them really useful for explicitly blocking specific IP addresses at the entire subnet level. So, the crucial point is really understanding how all these different layers and services fit together to form one cohesive security strategy. Let's go back to our blueprint and trace the complete flow one more time. Okay, so a legitimate request comes in from a user on the internet. First, it passes through the WAF for that Layer 7 inspection. Then, it gets routed through the Gateway Load Balancer to our firewall fleet for deep packet inspection. If it passes that check, it enters the subnet, where the network ACL allows it through.
And finally, it arrives at the instance's network interface, where the security group gives that final okay.
This whole layered approach, this is the official recommendation from AWS, and you can see how our model fits into it perfectly. We've covered the edge, the inspection, and the network layers. A complete architecture, of course, also includes controls at the application, compute, and data layers, making sure you have multiple, independent checks protecting your most valuable assets.
And that really is the key takeaway. No single layer here is a silver bullet. The true strength of this architecture comes from the tight integration of all these different components. It provides a security posture that is both deep, covering multiple potential failure points, and also really resilient against a wide variety of threats. So, building a robust architecture like this is absolutely the essential first step. But the next chapter in cloud security, well, it's about making that defense dynamic and intelligent. How do we automate detection, automate the response, and maybe even automate remediation? Now, that is the question that pushes us towards an even more advanced security posture.